Hi guys, in today's video we're going to take a look at what are reversible reactions, an analogy for dynamic equilibrium, the position of equilibrium, features of dynamic equilibrium, changing the position of equilibrium, looking at changing temperature, concentration, pressure, the presence of a catalyst, an exam style question, and finally a summary.
So let's begin by discussing what are reversible reactions. Well, you may well have met reversible reactions before, and they are represented with this symbol here with two half arrows facing in different directions. This sign is used to represent the fact that the reaction is at equilibrium. Although nothing appears to be happening, the system is actually constantly moving. It is dynamic. And a reversible reaction is only completely dynamic when it's isolated. What we mean by that is nothing is put in or taken out of the system. It's a completely closed system, and that's an important point. So let's take a look at an analogy of dynamic equilibrium so we can have a better understanding of what exactly it is. Well, if you're to hang your washing out to dry on the line, and then say it begins to rain, well, the rate at which your clothes are drying off and the rate at which they're getting wet are the same. This is an equilibrium. Although the system is constantly moving, your clothes are constantly getting wet and they are constantly drying. The rate at which they're both occurring is equal, and overall nothing appears to be happening. So now we've looked at what exactly our dynamic equilibrium is, let's take a look at the specific features of dynamic equilibrium. So in our dynamic equilibrium, at the same time our reactants are being converted into products, as is shown by our forwards arrow, and our products are being converted into reactants, as is shown by this backwards arrow. Now, our chemical system is truly in dynamic equilibrium when the concentration of our reactants and product is constant. Now, that's not to say that the concentration of reactants and products must be equal. They can be different, they just must be constant. In our system, the rate of forward reaction must also be the same as the rate of the reverse reaction, or the backwards reaction. So now we've taken a look at the features of our dynamic equilibrium. Let's take a look at the position of the equilibrium. Well, what is the position? The position of the equilibrium is the extent of the reaction. So it can lie close to the reactants or the product. So how do we change the position of the equilibrium? Well, the Chateliers Principle, an important principle, states that when a system in dynamic equilibrium is subjected to change, the position of the equilibrium will shift to minimise the change. So our system will move to minimise any change to the position of equilibrium.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, just click the Snap Provide smiley face. Join me today and together let's make A-level chemistry a walk in the park.